Yeah, welcome everyone. So we will have this talk in English, as I heard today, so this shouldn't be a problem. That's Philipp Schroedel and I'm Moser. So I just recognized that we didn't include our email addresses in the talk, but I guess you will find it anyway. This talk basically is about a plugin we have written during the last few basically months, but in fact it was during the last 4 days, completely rewritten, and at the end it wasn't a problem in the code, it was a hardware issue. It was really strange. Anyway, now it's working. What is the talk all about? What is this plugin all about? We will see that basically it's very simple. It adds to the Metasploit session and job handling ability. So this means that we can really start to define test cases and distribute the functionality of a exploitation framework or a botnet to the power of good of the enterprise.
So, hello everybody. We started the project actually because of a requirement, and we wanted to test some client configuration settings and stuff like that. We had searched different other products, and these are with the requirements of this tool. So if we are testing a client, we have to collect a large amount of data, we have to interpret them, we have to analyze them, visualize them to get proper reports and results actually.
Yeah, we actually thought for this talk, let's get a step back from our testing needs in terms of security test, product tests. And we thought, well, what's the general idea of testing? And testing in general is always, you have procedures for testing something, whatever it is. And usually you're collecting a lot of information, a lot of data in terms of computer testing. And then you somehow have to analyze it. So this was the whole basic idea then to try to ease up the recurring tasks, and especially if you look at, there's a slide. Oh, okay. If you look at security tests, there is a major problem if you want to do it at a larger scale. So the problem with testing usually is it works quite easy if you test one thing. It does not even have to be computed. But if you test a multiple thing with identical ideas, it's quite different to scale it. Especially now if you go into a network environment where you have different platforms, different policies, different behaviors maybe from the administrator, so it's quite challenging and it usually needs manual adoptions. I mean, you have your testing scripts, maybe you have your procedures where you follow, and then you adopt it. During the review of, let's say, the market, what is available out there, we recognize that the problem with automated testing, independent if it's a software or a software functionality test or vulnerability assessment, quite often you have just one single point of view in the result. So a software is trying, for example, that the intended functionality is working, but it never tells you anything about the underlying system. Or you have a network-based vulnerability assessment. Yeah, that's fine, but you don't get the configuration of the box if it's correctly configured. So, and then there are some tools which, for example, verify you the system configuration, but quite often does not take in consideration how the environment looks like. So we will see later on that you have quite a lot of specific needs if you want to do that in software, and you want to test your security of a system and measure actually the individual controls, how well did they work and did they work. Yeah. One of the specific tests which is not easily found in most products is, for example, something quite easy for a human being to test, is, let's call it outbound testing. So you want to verify that your restriction policy in the Explorer or in a proxy server actually works. So this sounds quite easy. Just go to a website and look if you get the right answers. But you can never tell which component, for example, is blocking the whole communication. Why it is blocking? Is it just because you cannot resolve DNS? Or is there a firewall, stuff like that? And the most difficult part is really the efficiency measurement. So which control was how effective if we turn to risk terms. So we try to abstract, basically really abstract that whole security testing. So you have something like vulnerability assessment, then you have some penetration tests. Likely when you're done with vulnerability assessments and you didn't find your way in, you usually do additional tests. This could be a host, a network, application. So really, let's say, search for stuff which is not discovered automatically because it's already well known. So this is usually a highly manual thing. And I mean, it depends on the scope. If you look from a testing environment on penetration test, maybe you have the need to gain access to the system, but this is quite often this is completely optional. I don't care about root if I get the data. But for sure you will collect a shitload of data if you do assessments. And you have to somehow consolidate the information and generate reports. And everyone which is doing tests know that the reporting is the most intense part. In fact, it's not really the reporting, it's the interpretation before you actually write the sentence. So the know-how between what you know, what your belly is telling you, what is going wrong in there, and the actual writing of the reports. Optional, I mean, that depends on your skill set and on your scope and in your environment. You have to pivot through a system to gain further access. For example, you get access to a unsecure web server, so you can pivot through that to gather additional information of the DM set, stuff like that. This really depends on the scope, but that's basically what we see as a very high level test for security systems. Doesn't work? Okay.
So this is how we, our idea, how we implemented the whole thing. The first thing we have to do is to get access to the client we want to test anyhow. This can be simply by executing a program, or can be archived through an exploit maybe, or executed via a login script or a software distribution mechanism. So we have a binary which has to be executed on the client. This is actually also different to most of the products we looked at. Most of them are based on an agent which must be installed, highly privileged, and
constantly running.
Constantly running, have open ports and probably also vulnerabilities.
Yeah, next the server, basically the client connects if it's executed to the server, and the server looks up for prepared test cases. And I mean, that's really the new thing. I mean, the rest is basically what Metasploit already provides you. So you can basically prepare test cases which needs to be executed. And yeah, at the end, tests can be started from the server side or from the client side, which allows you to collect information on both point of view. If you have a pivoting task, you can easily change that information additionally. So what is possible from the third hop or from the first one. So you basically, we will have some examples where you can easily see that, but the idea is that you collect both views, network side and internal one, and then you collect the data. So, yeah.
Then actually everything is collected by the server. At the moment this is stored with XML. In the near future maybe it's getting database based, or this is open at the moment.
It's easy to change it as you can imagine that's not really a problem. And at the end, there is a reporting task. This can be implemented. We have some examples here, but that's basically not part of our frameworks. It's completely up to you how to use it. So, in fact, we were using Metasploit to gain access. That's quite simple. It provides me a lot of different abilities. I mean, there are now Metasploit server-side part which is implemented in Java, in PHP, in DLL style. There's a POSIX one available. So if you get access to it, you can execute basically the server side of the Metasploit payload. So that's basically what we are basing on the server side, on the client, which will be attacked. I mean, it's pretty crazy with the client and server, but that's basically a server working on the client as long as you test. Then, I mean, Metasploit provides all the core functionalities, file searches, upload, download, registry. You can even directly call API calls. You can attach to memory. You can build basically whatever you want. It's not that easy always, but it provides the framework that can be easily used. Yeah, basically at the end we just extended the Metasploit language by further abstracting it to write simpler test cases, which an administrator should be able to do. So it's not always that easy to implement it natively using Metasploit scripts. And in fact, the session handling was completely missing. So this sounds like a botnet. Absolutely. I mean, yes, functionality-wise, it's exactly a botnet with a command and control center. It's kind of strange that the bad guys are actually having that already properly, and the market out there is quite split between compliance verification and vulnerability assessment, and in between there's not much. For example, a product for configuration validation is quite raw at the moment. I mean, even older products aren't existing anymore or replaced by a very cool compliance scanner, which actually cannot even handle anymore simple verification of registry keys. So it's really strange that the market does not have such products available, which aren't overblown or extremely expensive. So the next few slides describe the individual components. I guess we can just explain it right from the picture so we don't lose the context.
Yeah, so as we said, point one is the client-side executable. This gets executed the Metasploit session and connects back to the Metasploit framework. After that, the CARAT plugin takes over the session, looks up in a database based on the IP or the MAC address or CDR address of the client which is connecting, what jobs does the client has to execute, and reads these templates from a very simple instruction file.
Yeah, we call them instruction files. Basically, it's just a set of instructions. That's why we call it that way. Yeah, after it's getting the instructions, both sides can actually execute test cases. So either the server side can basically attack the client, or the client can collect the information. This allows you also some complex cases like outbound testing quite easily. Yeah, then when we collected the results, then we have another component, maybe.
Yeah, they get collected in a raw or XML file format, and after that a job gets executed which actually builds the report out of the collected data. But this is highly configurable. So
the whole idea was to not limit the ability by a given instruction set, which is, for example, in the beginning we started with ideas like, oh well, let's call it like verify user policy. And we decided at the end to change that whole idea and just put some, we call that atomic functions, so very small piece of functions, which, for example, upload, download, stuff like that, like in Metasploit, but it's highly abstracted, so it's easier, so you don't have to take care and pass stuff like that. And to allow then the user to have the full flexibility of using that individual commands in a script language style, which should be easier to handle. This allows a more flexible way, but has some drawbacks that you have even for simple tasks. Sometimes you have to write multiple statements, but you can save them aside and use them as a module during the next tests if you like.
Yeah, but on the other hand, we can make this whole thing platform independent. So it doesn't matter if you upload a file or the command doesn't differ from one system to another. So if you upload a file on a Unix, it looks the same like uploading a file in Windows.
Yeah. So the session handler basically decides on the session which command will be executed at the end. So I skip now the individual components. So basically, again, it looks like that. A client connects to the server. The server prepares basically some storage locations, checks for jobs, and then delivers instruction to be executed to the client and delivers instruction to itself to be executed. And at the end, the data gets collected and a report can be generated. And in this case, reviewed from the client, but it can be generated whenever you want. Why did we decide to not build in too many comments natively by ourselves? It's because we wanted to not limit the usage of a specific tool. For example, maybe a company does not like that you use the scanner X instead of scanner Y, or you have a specific software testing, functionality testing tool that you like to be uploaded and executed automatically if someone connects. You can easily exchange that. So basically, all the underlying commands are not included in the framework itself. I mean, we have some test cases already prepared. That's fine. We use most of the time functionalities already available on the end system, but it's your choice if you want, for example, to use MBSA by uploading them to the system, then execute it and take the report again and collect the information. I mean, that's not our scope to take care on what you actually do. That's the scope of the person which writes the test cases.
Yeah, if you are looking on some examples, what we can do with this plugin, one thing is we can check file and registry entries, make hash keys of them, something like Tripwire does actually. So we can verify the integrity of a system. So if you have a system set up, we can scan it one time and periodically afterwards and compare the different hash sums of the different files or registry keys.
Yeah, and it's not only configuration testing, you can also make functional and expected functionality testing, or for example, if you have a development team and they make a mistake, it will be fixed. You can write some test cases which always can be implemented during the testing procedures, that this bug is not re-implemented in that version, so you simply write one test case. A good example is as well, I mean, a lot of people using policies distribute them, but in fact, for example, the policy is not completely applied to the registry, especially if you're using standalone machine. That's quite complicated. So you can, for example, provide a policy file, which is available on your domain, but you can, for example, verify quite easily what's the actual registration setting against the intended settings of the policy. So you can differ basically and define what will happen if the policy is switched off or it cannot apply a certain setting. What's the setting of the system itself? So that's quite simple. Then automated software testing rules. It's quite well known in terms of functionality testing. There are some test cases out there. We don't have to write that by ourselves. In theory, we did not implement it so far. It is also possible to attach as a debugger on the remote system and fuzz it from the remote side and get information back. Or you can, especially if you have already a test case, a specific one, you can inspect memory attached to it, you can make new processes, whatever you like, and still having the control on the client side what information is actually going through. And the server can keep control of the data which is coming back from the server. So that's quite interesting, but we did not include that one as a demo here.
One example I also would like to mention is about forensic. So if you have to analyze a system after a break-in, yeah, the functionality is all there. So you can build hash sum from all files. You can make time tables, which file changed at which time, stuff like that.
Just to be clear, that's not for using as a where you don't change the system at all. I mean, for sure you need to execute an executable and change the landscape, but quite often you don't have that problem that you have to analyze it offline, but you can, for example, really quickly define it once and search for certain appearances in the different clients. So yes, forensically, but not in terms of a non-changeable system. I mean, it's a running system and you run something on that device. It's quite cool. Metasploit provides us a functionality to execute something in a dummy process. That's quite okay. So you don't have to actually upload and install the whole binary thing. There are some limitations, but that's quite cool. So you don't have to really upload the application every time. The real need gets basically explained best if you take two examples. So here we have the inbound test. So for example, I execute on the client a simple command -nr -ARN, and I will get some lists of listening port states. Then I can get the configuration of the local firewall as well, for example. And I can execute a network scan from the outside as well, from the server. So, I mean, that's quite simple. The cool thing is that I can start that from one location, but the real power is now that I can collect that information. I mean, for sure, yes, it's quite challenging to write those test cases, but you do it once. And independently how you enter a system, you can still execute the test cases as far you can manage to execute a server, a Metasploit server component on the client. So, I mean, that's pretty obvious. And in the other direction, outbound, that's quite complicated for a lot of products these days, and it's quite simple in here.
Yeah, so the first step is that we ask the client to do some name resolution. So we ask the local installed Internet Explorer, for example, to resolve IBM.com or porn or level.com. If this is working, then we again get the firewall configuration and look at the settings, which connection would get blocked on the client itself. And then we ask the client to actually do the connections to fake the servers on the CARAT server, and then we can verify these settings. So in this example, it would be possible for the Internet Explorer to get to www.evel.com, but some kind of firewall in between is blocking the request.
So this allows you, for example, make an assumption, well, the local firewall does not block that website, so there's another mechanism in place. Or you can use it for validating your, for example, whitelisting of your proxy server or network boundaries, stuff like that. So we have prepared. Oh, I did not start. Let's start there. So now I switch to mirror mode so you can see it as well. So I can try it. Better? Okay, I mean, in the beginning we had a web GUI. That's the last task we finish now because we initially quick prototype it in PHP and the rest is Ruby, so this doesn't make sense, so we will port it over. And for additional larger scale testing, we need a client interface which is command line based anyway. So this is basically the command line interface, and this allows you just to add tasks, delete tasks. You can modify the database. That's just basically the database which holds, it's in fact SQLite at the moment, which holds just the actual job. So it's quite straightforward. You have a job number which is unique, you have some comments, then you have a status of the job, you have the matching filters, and you have some templates which the jobs are based on. So you can make templates, for example, here outbound testing, assign that one to a specific IP or a range, or that's a range or a MAC address, and it will pick the most specific one. So I just prepared 3 of them. That's IP 3, 4, and 5. So I will change the IP of my target to show it to you. Let's. I will start it with enhanced user rights because I will use fake daemons on port 80 and 53, so I need to have higher privileges. Yeah, and wow, it's just loading an additional plugin with some parameters. That's all. And the first one is a small, let's call it inventory scan. Come on. Okay. Just let me. Okay. So that's for income. Connections up. That should do the trick. Seems like we are losing the network connection when we're suspending the VMware. Okay, now let's try it again. Okay, over there it just says, well, there is a connection. It sends over the rest of the Metasploit server side, and then it starts to build up an environment on the client, just a temporary directory. It's not needed if you don't have a test case for it. For example, if you don't need to upload files or you don't need to download a specific file in that directory, you don't have a need for that one. Then it uses a functionality called Railgun to make a native API call on the client just to tell them, well, there's a message box. Later on, in the background, now all the commands get executed. I mean, that's not very special. I just let it run in there and open it up. There. So let's open. Yeah, it's okay. Yeah. Oh. Excellent. So just, I mean, now it's scanning actually, what's the unique identification? That's 4885. Wrong window. That's that one. So, for example, in here there is always a file called main instruction. This is basically some set of commands to be executed. Vehicle. Yeah. Pretty straightforward, actually. There is a difference between a remote execute and remote execute read. It's just redirecting the standard out to the server, so to directly save the information there. You have some let's say cleanup functionalities which downloads the directory from the client and remove it pretty root in here. And then you have some statements about where we start, where we end, and then we have some includes. I mean, for making such a thing useful, you have to have some includes. For example, for nmap, it's quite trivial, just a command. For winenum, for example, in here we just do that net start, and there are a bunch of other commands which will not be executed, otherwise it takes too long. And for wmic, for just querying the configuration database, that's quite straightforward. A neat trick is that I use a small tool which actually gets the clipboards. The problem with Vmic seems to be that the output is somehow strangely buffered, so you cannot just redirect the output, otherwise the console will hang. That's a quite common problem. So you normally have to locally store first the files and then transfer it. We find a way to use the clipboard as a temporary storage, so you don't have actually written files to disk. That's the whole idea of it. I mean, the nice thing is that you can easily also make a test case for repeatedly steal information from clipboards. Could be an issue if you use password managers. But I mean, it's quite straightforward. You just tell them what to execute. You have a status, and you have a file which is called report.gen in here, and that's basically just triggered at the end of the functionality down here, and which will, in that case, specific case, will convert some text files into XML and copy it to a different folder, and at the end execute XML transformation. And at the end, you get a report. By the time it's finished, if you scroll up in that log, you will see that nmap was running. That's from the server side. And if we look now at the report in this example, so, I mean, that's just a RT report I quickly hacked together using the last few hours. I mean, there's just a text and a table. I mean, that's pretty straightforward out of the XML, nothing fancy. The really cool thing is, I mean, we generated in the report generator some statistics, and down here, for example, you can now easily get the output of netstart and, for example, color it, or I just added as text in here, the state gathered from the nmap. So this just shows you that basically that information is validated from the outside. And if you look at the table, you can easily identify, well, there's one port down here, and it's established. And yeah, first of all, I just scanned the first 1,000 ports, so it wouldn't be detected at all, even if it's listening. And I mean, I hope you get the idea out of it. So you can have multiple different information sources, and you can handle it from one testing location. I'm pretty much sure if you do testing, you have to take care of such stuff by yourself by now and adopt to your client's environment. So let's change it to another IP address. That's the, just check which one. outbound is the IP 3. For example, the outbound testing. So again, the same setup. Just execute the same executable again, because now it has a different IP address. The client gets another template. So again, a message box will be displayed. It's quite crazy that this display of the message box actually took so long. I mean, it's 2 API calls natively out of Raygun, but it takes quite a lot of time to execute it. I don't know why. I did not investigate how they really did it. And now you can see that in that case scenario, which start first 2 auxiliary modules of Metasploit, and this shows that you can use the power of Metasploit basically as well. So we start a fake DNS daemon and a slightly modified HTTP capture daemon, which just basically saves all the requests coming in. And that's 37 and 92. Yeah, absolutely perfect. 7, 92, that's the one. If you look at that instruction file, maybe I just open again the whole directory. Open with applications. Yeah, search again. TextMate. So if you look at that one, for example, it's quite easy. I mean, I have made a different file for the outbound testing in here, which basically first start the auxiliary services. I mean, that's quite easy to do. You just specify what the module parameter, then you execute basically. I did not have the time to do that natively using Raygun, so I used basically a Visual Basic script which calls the Internet Explorer. That's because I'm not at the desktop at the moment when I'm in Metasploit. I can migrate to Explorer XE. This could be automated as well, because you can also execute any existing Metasploit script from inside that CARAT plugin as well. So, and then I just try to force the client to connect porn.com. I mean, the fake server will answer that request if it gets there. And yeah, at the end I write some statements into an XML file, what command was sent to the client, just to keep track of it. So the outcome of it would be saved into a very simple XML structure, which is really abused just for simplicity. Basically just the 2 requests which were collected. I sent 3. I mean, those were the 3, porn, heise, and good. And I slightly modified the reporting generation just to collect that information. And when I now look at this report, I mean, reporting is completely up to you how to do it. I just made a table out of it. So basically, it's XSL with some XPath in it and magic. It just sees what was requested, what was received, and at the end you can see, well, www.porn is failed or blocked. In that case, depends on how you look at it. And heise and good was received by the server. And now you can add further information like configuration for your firewall, stuff like that. This was just what was sent, what was received, somewhere is a gap. So this should show you that even in more complicated environment, this should work. So the last one, yeah, we can one as well. 39. Yeah, I can. I don't think that I have to execute. Close that one. So the job 39 basically is something like it's something like a SHA-1 sum collector. The problem is really if you could, for example, use a tool which is collecting your MD5s without actually writing it to the disk using that fake dummy process in memory injection concept. But the problem is that you cannot provide arguments to that specific one at the moment, at least how it's implemented. So I had to upload it first and execute it for a simple demo. So basically, it just collects some hashes, and it just put it into the raw directory for now. And you could easily right now report that compares, for example, that hashes to another one. So, I mean, if you, for example, have certain versions of your application, you can use that not maybe forensically, but to ensure that the application or the individual files are really the same. I mean, searching for a specific DLL based on version does not might be a good idea, so you use the hash. This could be a good example for that. So for the structure, it's quite easy. If you check out the Git, you just link 3 files into the directory of Metasploit. One is the plugin itself. One is the startup script, which can be executed using parameter R on Metasploit. And after that, you just have all the information below the plugin. And it's quite simple. You have something where the code is, and you have a template directory where all templates are available. So for example, I use that outbound test. It's down in here. If I add a new client, it will be copied into a new directory which has a top number. At the moment, it's file system based because of some requirements we had in the beginning. And I mean, I guess you get the idea of how the individual jobs, I guess 33 was it, will be copied over. And if the client then really connects and executes the job, the results will be handled into the results directory. And for example, down here 37. And as you can see, you can have multiple. I mean, if you run the same test twice on the same computer, you don't want to overwrite the test with the next one. So you have some differences. So we make some unique numbering out of it to ensure that it's not overwritten. That's basically the whole story about structure. I mean, it's not that fancy. So now back to, I guess, 3 slides. The question is, does it scale?
Yeah, yes, for sure. We can have multiple instances of the Metasploit and CARAT server instances, maybe in different networks. They can have separate databases. They can connect to one database, to a common database. Yeah.
The idea for the next future is including a native OVAL interpreter. So OVAL is basically a descriptive language based around XML, where you define test cases for vulnerabilities, configuration, and what else? Compliance checks. The nice thing is that it's based on the vulnerability databases, and you get every month new test cases for the common vulnerabilities, so you don't have to write them for your own. At the moment, you can easily take the default tune for them from their website, upload it, and add individual XML if you like. But we think that it makes absolutely sense to at least allow a user to use the same language to define test cases, because we are lazy and we want to save ourselves some time. So this would save us a lot of time in terms of NIST checking or compliance. For example, there are tests for, is there any USB device connected? So I don't have to write that by now. The next thing is the platform abstraction to implement it for real. The problem is that at the time we started, the POSIX one was not available, and now it's available, so it should be an easy task to just split that up. And rebuilding of the web GUI, which is basically the last task that we do, because it's just for easy management. The idea is that you have all your test cases in the templates, and you can choose which instructions you want to merge and then execute it. But the design of that whole idea is that you have to know what you're actually doing. So it just helps you by providing you a scheduler, nothing more, nothing less. So it's not that fancy, but it provides you exactly the missing piece between using individual Metasploit scripts and adapt it to the different scenarios to fully automating using the power of the individual components. Basically, we are done. I have 2 questions already prepared and answered. Yes, it can be abused, and yes, it provides you some insecurity. I mean, it's up to you to remove exploitation abilities of Metasploit if you don't like it. There is a SSL support available, which always generates a new certificate. That's maybe not the intended use in that case, but you can easily remove that and provide a defined SSL certificate so not everyone can connect. And yeah, other than that, I mean, for sure, it needs the appropriate context and user rights. But the cool thing is you can adopt your use cases to your environment. So, for example, you can verify first, was it a Metasploit or running a system on a Windows system, or is it a PHP version running inside of the web server process, so you don't have that much privilege, and you can easily detect that and react accordingly. And yeah, that's basically the whole thing about it. And where can you download it? We did not manage to implement the Git openly at the moment, so it's still depending on your SSH key. The IT operation department within Dreamlab is fixing that, I guess during the next few days. If you need access, just send me an email and I will add a key for you, and then you can just get it out of the Git. And then it's pretty straightforward. It's simple Ruby. We don't use too much object orientation programming because it simply does not make sense in that context, because you have one object, that's the session, and the rest is basically operating top-down on new instructions. So yes, it has some, but it's pretty easy code to read and write. And if you want to provide test cases, feel free. Yeah, you can reach us on our website. So now for questions. Okay, so overall ready. We're faster than expected. Thank you. Okay.